Algebra I 9.4a, Conjunctions and Inequalities. We know that the absolute value of x equals 3 can be 3 or negative 3. Now, if that's confusing, that means you missed the previous video, and in this description there's going to be a link to that one, so you can just click on it before you watch this one, okay? That's my best advice. If you did watch it, let's keep going. For the absolute value of x to be less than 3, then any value between a positive 3 or a negative 3 will make this true. Now, it doesn't include positive 3 or negative 3 because it just says less than, okay? It doesn't have the or equal to bar underneath it, does it? So, for it to be between a positive 3 and a negative 3, and not including it, we have our open dot on the negative 3 and the positive 3, and we know it's all the values in between when we graph it, right? We can write the solution as a conjunction with and, as x is less than a positive 3 and x is greater than a negative 3. Now pay attention to this sign here with the negative 3. It can also be written in the condensed form with the sign switched around, because you notice the x is on the left and the negative 3 is on the right. Now the x is on this side and the negative 3 is on the left. So because of that, we had to flip that sign around, because the bigger part of the sign needed to be open towards the x. See? It needs to be open towards the x. So the sign was reversed in order to write it in this condensed form, okay? So it means the same thing whether x is greater than negative 3 or negative 3 is less than x. It's the same thing. They equal each other, okay? We can also write this in set builder notation with our set braces and our such that bar. We could write it with the variable x and then write it as we did here in the condensed form right after that such that bar. See that? It's the same thing. The only difference is the set braces, the x, and that such that bar. And we'd read this as the set of all x such that x is greater than negative 3 and x is less than 3. All right? So to solve an inequality in the form the absolute value of a is less than b, where b is a positive number, we solve the conjunction. A is greater than negative b and a is less than b. And remember, when you see it like this with two inequality signs, you start reading in the middle. A is greater than negative b, a is less than b, okay? Don't start here. Two inequality signs, start reading in the middle, okay? A similar rule is true when there's a less than or equal to sign, okay? So to solve and graph the absolute value of 3x is less than 15, we solve the conjunction as, here it's in condensed form, see? Remember, we're going to pull the negative 15 and the positive 15 out of this. So now we've got 3x is greater than negative 15 and 3x is less than 15. We start by rewriting it using the word and then solve them each separately. So we've got this side, negative 15 is less than 3x, and then we've got this side, 3x is greater than 15. We put and in the middle. See how there was one 3x in the condensed form, and when we opened it up with and, there's two 3x's with the and in the center. See that? So now we've got negative 15 is less than 3x, and 3x is less than positive 15. All we need to do is divide each side by this coefficient 3 to simplify it, right? So this side becomes negative 5 is less than x, because this makes our buddy the invisible 1 identity property, doesn't it? And on this side, same thing. Here's our buddy again, invisible 1 and identity property. We get x is less than 5 when we simplify it, see? We can abbreviate this to condensed form, all right? So we had it like this in condensed form from the equation with absolute value. Now we've got it down to here because it's been simplified, okay? And it's abbreviated in condensed form. So x is greater than negative 5 and x is less than 5. And when we graph it, because it doesn't include negative 5 or 5, we put the open circle and it's all the values in between. And if you want to do it my way with the parentheses, then we would put a parentheses on the negative 5 because it's not included, and one on the positive 5 because it's not included, but all the ones in between are. Our solution set with set braces and the x and the such that bar becomes the set of all x such that x is, remember we start in the middle, greater than negative 5 and less than 5. See? All right. So remember, if the number is not included, You use an open dot, or you can do my way and use the parentheses, like we're going to do in Algebra 2 anyway, okay? And that's when it's less than or greater than. And when the number is included, it's because it's got the bar for or equal to. And then we use a filled in dot, or we use the Algebra 2 my way of the box bracket, right? Okay, so a lathe operator is making gears, all right? He's making these gears. In fact, what they do in the factory is they actually take a circular piece of steel or metal, and the machine cuts these notches for the gear into the side. Isn't that something? That's a bench lathe machine. It goes and sits on a bench, so it's at waist height so the person can work it, and then they can cut the gears, see? Isn't that cool? So a lathe operator is making gears, and the specific instructions, the specifications, require that the diameter, remember, from side to side, of the gear fits this inequality. The absolute value of d minus 2, diameter minus 2, has to be less than or equal to 1/100th of a centimeter. So remember, 0.01 is equal to 1/100th, right? So that's what they're saying, all right? So we got it in decimal form. So what are the acceptable diameters of this gear? Well, we solve the conjunction, and we take this and put the d minus 2 in the center, and it's less than or equal to a negative 0.01 or a positive. It's less than or equal to, it's greater than this one, but less than this one, see? 0.01 on the positive side. Now notice I put a 0 in front of here. See? Now I don't normally do that. I would have just put 0.01. But in this one, I put 0.01. It's because I'm getting ready to add that whole number 2 to make 0 pairs. I saw this minus 2 and said, okay, I'm going to have to make a 0 pair. So I'm going to put the whole number place value here so that I can do that, okay? So first we rewrite it using and then solve them separately. So we take this side, negative 0.01 is less than or equal to d minus 2. As our first one, we write and then we repeat the d minus 2 and then put less than or equal to 0.01 for the second one, see? Now we can add that 2.0, all right? So it would go into this place value, wouldn't it? Because it's a whole number, all right? And this is 100th. So now, if you've got a negative 0.01 and you add 2 whole ones to it, you've got a 1.99 that's positive, don't you? And this minus 2 and plus 2 made a 0 pair, and it got eliminated. So now we've got 1.99 is less than or equal to d, and on this side, we create a 0 pair by adding 2 to each side, so that's gone. And we get d is less than or equal to, we've got 2.01, see? Make sure your place values are lined up, okay? Now we can rewrite our answer in the condensed form with only one d. Take these 2 d's and condense it into 1 and take the word and out. And we've got d is greater than or equal to 1.99, or d is less than or equal to 2.01. So the gear's diameters can be anywhere from 1.99 centimeters to 2.01 centimeters, and they'll fit whatever they're supposed to go into. Okay? That's a big difference, isn't it? The solution set written in set builder notation would be as with the set braces, and then d, because that's what we were solving for in our such that bar, and it would be d such that all d is greater than or equal to 1.99 or less than or equal to 2.01. See? All right. If this was really confusing, you need to go back to these videos here, because we talked about equations and absolute value and solving conjunctions and intersections, and even how to write in set builder notation. So if you're confused, you missed these videos and you need to go back into these links, okay? So our next video, 9.4b, we're going to talk about disjunctions and inequalities. This one was conjunctions with and. We're going to talk about disjunctions with or. And of course, all these links will be in this description to help you, okay? Just remember, each of my videos builds upon the previous one. So if you're missing some of my videos, you're missing what I'm saying and can get confused in future videos. All right? And it's not that big of a deal to watch a few-minute video to be able to understand what's going on, right? It's not like you have to sit in an hour classroom, right? Okay. I'll see you next video, and I hope you're doing okay. Keep your chin up. We'll make it. Bye.